Okay, so let's talk about how to write radiation formulas. These are going to be easier than you think. They look complicated, but they're actually not terrible. So the first thing that we'll do, we'll always have a sentence like this: technetium 100 emits an alpha particle. Now you want to make sure that you always have a periodic table while you're doing it. Get very lost and you're not going to understand what the heck I'm doing. So go ahead, make sure that you've got a periodic table to help you out with this. So first we're going to go ahead and we're going to find technetium on the periodic table. And I know that technetium is Tc, and its atomic number is 43. The number of protons it has is 43. That number always goes on the bottom, and on the top is the atomic mass, which I have given in the problem here is 100. And whenever we say emits, that just means arrow. That just means we're going to draw an arrow like this. So technetium 100 emits, and then alpha particle. And an alpha particle, which you need to know, is this right here, 42He, because it's a helium nucleus. So it emits that, and then the thing that we need to do is decide what should go with it. Now this is actually going to be easier than you think. So what you need to do is you need to look at your numbers, and you need to think of this arrow as if it's an equals sign. So if I said equals right here, and I had 43 equals 2 plus, you'd be able to figure this out, right? So you could just go backwards, and we find out that we need to put a 41 down here. So to check your work, you'd read it forwards. 41 plus 2 equals 43. That all works. Across the top, we do the same thing. This time it's 100 is equal to 4 plus something. In this case, it's 96. And then we've got our top numbers. We can check it the same way. 96 plus 4 equals 100. Then we're going to take our periodic table again, and we're going to find number 41 right here. And in this case, number 41 is niobium, which is Nb. And that's how we do these formulas. That's what they look like. So let's go ahead. We're going to do another one here. This one is beta plus. I'll go ahead and show you right now what beta plus is. And I want you guys to see if you can do this on your own. So go ahead, pause the video, give this one a shot. Okay, so here we go. Neodymium 147. Neodymium is it's a lanthanide, so you need to make sure that you're down on that bottom 2 rows of the periodic table. And it's number 60. Its symbol is Nd, and it is number 60, 147 on top. Emits, and then we are going to go ahead and put in our beta plus particle, E0 plus 1, and then the last thing that we need to do is include the last nuclear symbol here. It's the same as before. We're going to make sure that across the top and the bottom our numbers will make sense. So 147 plus 0 is equal to 147. That one is always going to stay the same with beta. But on the bottom here, we're going to end up being 59 because 59 plus 1 equals 60. So that's what that is. Then we just got to go and find number 59 on the periodic table, which in this case is praseodymium, which is Pr. And that's how that one's done. One more here for you guys. Write the formula of uranium-242 emitting a beta minus particle. Beta minus is this symbol right here. Give this one a shot. Okay, so we're going to write uranium right here. Uranium symbol is a U. It's number 92, and it has number 242. Emits beta minus particle. Now this is where it can get hard. Because this is a minus, you have to treat it like it's a negative number. So in this case, we're just going to go ahead and go 92 equals -1 plus, and in this case, it's going to be 93. On the top, it doesn't change. It's still 242. But now instead of being uranium, it's actually neptunium, Np. So beta minus are the hardest ones. You guys always get tripped up by this -1 right here. So just be careful and make sure that you're paying attention.